Sixth one, worked example. It's a good question. Annual 2016, annual 17, model question paper, even in handbook also. So, given solution, given f from natural numbers to real numbers, defined by f of x is equal to 4x square plus 12x plus 15, say some equation 1. For all x belongs to natural numbers, let f of x is equal to y. What is f of x? 4x square plus 12x plus 15 is equal to y. We are supposed to solve for x from this equation. So till now we have a linear equation, right? Only one quadratic x square plus 4, but this is a complicated one. I mean, you need to solve for x by completion of a square method. See, observe the term 4x square can be written as 2x the whole square. This is actually 2ab term, a square 2ab plus b square we want. Let us recognize b. See this, 4x square can be written as 2x the whole square plus 2a is 2x, you know. 2 into 2 is what? 4. I want 12, you know. 4 into 3, 12. Observe now, 2 into 2 into 3, 12x only. No change in the value. So this is b actually. I just add b square. To balance it, I have subtracted b square. 15 as it is equal to y. Now observe these three terms. A square plus b square plus 2a into b, a plus b whole square, 2x plus 3 the whole square. Now 15 minus 9 is 6, 6 to the other side, y minus 6. So 2x plus 3 is equal to root of y minus 3. Shift 3 to the other side, root y minus 6, put a bracket, minus 3. So 2x is equal to this means x is equal to root of y minus 6 minus 3 divided by 2. Clearly, see this should not be imaginary, right? This should not be negative, I mean. So y minus 6 should be greater than 0. Y minus 6 greater than 0. It can be 0 also, no problem. Because 0 minus 3 means minus 3 by 2. No problem. So, y greater or equal to 6. Greater or equal to 6 means including 6 up to infinity. So, therefore, s is equal to 6 comma infinity, which is range of the function. Now, let us define, see the question, show that f from n to s, n to r iddiddu, n to s anta aitu, range of the function. Now, g from b to a, you know, s to n, g from s to n, defined by g of y is equal to x. G of y equals x means what? This, you know. So, root of y minus 6 minus 3 divided by 2. For all y belongs to 6 to infinity, closed interval 6 up to plus infinity. Say some equation 2. So this fetch you the first mark. Now for all x belongs to n codomain, g of x is equal to g of f of x. Please observe f of x from equation 1. F of x is nothing but 4x square plus 12x plus 15. Now this is of the form g of y. Using 2, g of y means what? Root of y minus 6 minus 3 divided by 2. G of t means what? Root of t minus 6 minus 3 divided by 2. G of this means what? Root of this minus 6 minus 3 divided by 2. 15 minus 6 means 9. 9 can be written as 3 square. 4x square is 2x whole square. This is 2ab term. So, 2x the whole square plus 2 into 2x into 3 plus 9 can be written as 2x plus 3 whole square, you know, under root. Square and the square root gets cancelled. Minus 3 divided by 2. 2x plus 3 minus 3 means plus 3 minus 3 gets cancelled. 2x divided by 2 means we are left with x. So therefore, GOF is an identity function on the set of domains. So say some equation A. So that gives one more mark, the second mark let us say. And for all y belongs to the range of the function, that is a closed interval 6 to infinity, fog of y is equal to f of g of y. Look at g of y. G of y means from equation 2, root of y minus 6 minus 3 divided by 2. I have written here. This is just like f of x. Please observe carefully. F of x. From equation 1, we can write this as, so 4x square, 4x square. This is x actually. 4 into square of this. Square for numerator, square for denominator also. Right? 4x square. This is completely x. Okay? Plus 12 into x. X means this quantity I have written here. Plus 15 using equation 1. Now 2 square means 4, this 4 and this 4 gets cancelled. Now this is of the form a minus b the whole square. A minus b whole square means a square. Square and the square root gets cancelled. Y minus 6. B square means 3 square 9 minus 2 into root y minus 6 into 3. 2 into 3 means 6. Minus 6 into root of y minus 6. Here 2 1 times 2 6 times. 6 times this expression minus 3 plus 15 is there. Now y 9 minus 6 means 3, this is 2 into 3. Minus 6 into root of y minus 6. Multiply with minus for these two. 6 times root y minus 6. 6 into 3, 18, minus 18 plus 15. See this, plus 6 root y minus x, minus 6 root y minus x gets cancelled. Observe this, 15 minus 18, minus 3. This is plus 3, So, plus 3 and this is minus 3 gets cancelled. We are left with only y. Fog of y equals y. Therefore, fog is identity function on the set of S, which is nothing but 6 to infinity. Say some equation B. That gives one more mark. Now, see that up to here we obtain only 3 mark. Please note that. Okay. So, using A and B for writing the conclusion only, you get one more mark. 2 marks left out now. So, F inverse equals G, 1 mark. Already we have assumed G from S to N defined by G of y is equal to x, G is nothing but F inverse. So, F inverse equals root of y minus 6 minus 3 divided by 2 for all y belongs to 6 comma infinity. That is the 5th mark. For the same problem, let us discuss an alternate method. So, if it is invertible means it should be bijective. If it is to be bijective, it has to satisfy 1 1 and onto. 1 1 and onto means bijective. If it is bijective, then only inverse of the function exists. That is one of the definition for invertible function. And identity function, GOF is identity function on the set A, that is domain, and fog is identity function on the set B, that is codomain. If those two satisfies, then F is invertible. F is invertible. That is the method we have discussed till now. So, for the same problem, I am going to discuss an alternate method, that is by using 1 1 and onto I am going to find the inverse. Both the methods are correct. You can follow any of the method. Okay. So, for both the method you will get the marks. Don't worry. Okay. So, whichever you feel comfortable, you can go for that only. But in NCERT, they have discussed using the first method only, fog and GOF. So, better to follow that. But this is also correct method only. Okay. Solution. Given f from n to r defined by f of x is equal to 4x square plus 12x plus 15 for all x belongs to n. Let us verify one function. For all two elements belongs to the set of natural numbers x1 and x2, then f of x1 equals f of x2. F of x is this. F of x1 means 4x1 square plus 12x1 plus 15. F of x2 means 4x2 square plus 12x2 plus 15. Now 15 and 15 gets cancelled. Between these two, I shift this to the LHS. 4x1 square minus 4x2 square plus between these two, 12x1 minus 12x2 is equal to 0. Between these two I have taken 4 common, x1 square minus x2 square plus between these two I have taken 12 common, x1 minus x2 equals 0. See, this can be written as x plus 1 into x minus x1 plus x2 into x1 minus x2. You know, here also x1 minus x2 we have. I just take 4 also common. 4 times x1 minus x2 common means here we are left with a plus b. I mean x1 plus x2 for 3 times 12. This means 4 cannot be 0. x1 minus x2 equals 0 or this is equal to 0. This equals 0 means x1 plus x2 becomes minus 3. This is not possible. Why? Because x1 and x2 are natural numbers, you know. If you add any two natural number, it must be a natural number. It can't be minus 3. So x1 plus x2 must be greater than 0 only. That's why this is not possible. So only x1 minus x2 equals 0. So that x1 is equal to x2. F of x1 equals f of x2 implies x1 equals x2. Therefore, f is 1 function. Let us verify on to. For all y belongs to the codomain, that is range of the function 6 to infinity, closed interval 6 up to infinity, then f of x is equal to y. There exists x belongs to n. Let us verify this. F of x is what? 4x square plus 12x plus 15 is equal to y. So to solve for x, we need to apply completion of square method, you know. So we have followed in the previous method also. So 4x square can be written as 2x the whole square. 2ab term this is. So 2 into a is 2x. If it is 2b 12, 2 into 2 4. 4 into 3 means 12x. So into b square I have added to b square I have added. To balance it, I just subtract 3 square plus 15 as it is equal to y. 15 minus 9 means 6. To the other side minus x. 2x plus 3 the whole square is equal to y minus 6. Y minus 6. So that 2x plus 3 is equal to, so that 2x plus 3 is equal to root of y minus 6. 2x is equal to root of y minus 6 minus 3, you know. X is equal to root of y minus 6 minus 3 divided by 2. Clearly this belongs to natural number as y greater or equal to 6. Don't get confused, students. Here y is equal to 2x plus 3 the whole square plus 6 is there, you know. You need to select y in such a way that x should be natural number. Suppose if I take a natural number 1, let us say x has 1, 2 into 1, 2 plus 3 is 5, 5 square 25, 25 plus 6 means 31. Come to here, y is 31, 31 minus 6 means what? 31 minus 6, 25, root 25 means 5, 5 minus 3 means 2 by 2 is 1, which is a natural number. Or else, let me take one more example. X has 2, 2 is a natural number, x a natural number, 2 into 2, 4 plus 3, 7, 7 square means 49, 49 plus 6 is 55, 55 minus 6 means 49, 49, root 49 means 7, 7 minus 3 is 4, 4 by 2 means 2, is again a natural number, okay. So you cannot take whatever the value you like for y. So you need to select in such a way that y should be equal to this. So therefore, f is onto function. Clearly it belongs to natural number. F is onto function. Now, since f is both 1, 1 and onto, f inverse exists. To find f inverse, let f of x is equal to y. X is equal to f inverse of y, So just now we obtained the value of x. I just write it directly. The value of x is this one using equation 1. So f inverse of y equals root of y minus x minus 3 divided by 6. The next question, 7th one, an exercise problem. Consider f from set of positive real numbers to the set closed interval minus 5 comma infinity given by f of x is equal to 9x square plus 6x minus 5. Show that f is invertible with f inverse of y equals root of y plus 6 minus 1 divided by 3. It's there in the model paper. So the same type of problem, previous one, it is appeared twice. So this is the problems which is left unasked. So we can expect this for your examination, a good question. The same question can be asked like this. If R plus is the set of all non-negative real numbers, prove that the function f from set of positive real numbers to the set minus 5 closed interval minus 5 to infinity defined by f of x is equal to 9x square plus 6x minus 5 is invertible. Also write inverse of f they are asking. Solution. Given f from R plus to the closed interval minus 5 comma infinity defined by f of x is equal to 9x square plus 6x minus 5. Say some equation 1 for all x belongs to the domain set of positive real numbers. Let f of x is equal to y. What is f of x? 9x square plus 6x minus 5 is equal to y. So again we need to solve for x by completion of square method. What we did in the previous problem, same procedure. 9x square can be written as 3x the whole square. This is 2ab term. 2a is 3x. What should be b? 2 into 3 is already 6. So I should take b as 1. Whereas in the previous problem it was 12 actually. 2 into 2, 4 into 3 I have taken 12 if it is to be 1200. So now b is 1. So 1 square I have added. To balance it I subtracted 1 square. Minus 5 is equal to y. Now these three terms a square plus b square plus 2a into b, a plus b whole square minus 1 minus 5 means minus 6 is equal to y. Shift this to the other side. Y plus 6 under root 3x plus 1 whole square, So 3x equals root of y plus 6 minus 1 into 3 means divided by 3. That is the value of x. So f from a to b means invertible function. G from b to a. You need to assume let g from minus 5 comma infinity, closed interval minus 5 comma infinity to a positive real numbers defined by g of y is equal to x. G of y equals x means x is nothing but root of y plus 6 minus 1 divided by 3 for all y belongs to the closed interval minus 5 comma infinity. So once you obtain equation 2, you get the first mark. Now for all x belongs to R plus positive real numbers, domain I mean, gaf of x is equal to g of f of x. Look at f of x from equation 1, 9x square plus 6x minus 5, you know. So this is just like g of y. What is g of y? Root of y plus 6 minus 1 divided by 3 using equation 2. So this is completely x, I mean y. So root of y plus 6, that is 9x square plus 6x minus 5 plus 6 minus 1 divided by 3. See this, 6 minus 5 is 1. 9x square can be written as 3x the whole square. 2 into 3x into 3x plus 1. So can be written as 3x plus 1 the whole square under root. Square and the square root gets cancelled. Okay. So minus 1 divided by 3. So plus 1 and minus 1 also gets cancelled. 3x divided by 3 means we are left with x. So therefore gaf of x is equal to x. Gaf is an identity function on the set of domain, that is set of real numbers, positive real numbers. Say some equation A. You will get one more mark for this step. And for all y belongs to the range minus 5 comma infinity. So fog of y, we operate g, you know. So y you should take. Here we operate f, you know. You take x. Okay. So fog of y equals f of g of y. Look at g of y. G of y is from equation 2, root of y plus 6 minus 1 divided by 3. This is just like f of x. What is f of x? 9x square plus 6x minus 5, you know. This is completely x. 9 into this square, numerator square, divided by 3 square, denominator square means 3 square 9 with this 9 gets cancelled, plus 6 into x means this is completely 6 into root y plus 6 minus 1 by 3, 3 1 times, 3 2 times, 3 2 times, minus 5 as it is by using equation 1. This is of the form a minus b the whole square, you know. A square, square and the square root gets cancelled. B square means 1 minus 2 a into b, 2 root of y plus 6 plus 2 into this means 2 into root y plus 6 minus 2 minus 5 minus 1 minus 5 as it is. Now remove the bracket. Y plus 6, 6 plus 1 is 7 minus 2 root y plus 6, multiply with the 2 root y plus 6 minus 2 minus 5 is minus 7. With this plus 7 gets cancelled. We are left with y, you know. Fog of y is equal to y. Therefore fog is an identity function on the set minus 5 comma infinity. Say some equation b. So till this you get the third mark, one more mark for this. So now conclude. From A and B, clearly f is invertible with f inverse is equal to g. You get one more mark for this conclusion only, you get one more mark. Okay. Another mark, we have assumed g from B to A, you know, minus 5 comma infinity to set of positive real numbers defined by g, f inverse of y equals g of y. Therefore f inverse of y equals g of y is from equation 2, root of y plus 6 minus 1 by 3 for all y belongs to minus 5, closed interval minus 5 comma infinity. So that is the last mark, I mean the fifth mark. Okay. So this is a very good question. Eighth one, exercise problem. Show that the function f from the closed interval minus 1 comma 1 to a real number given by f of x is equal to x divided by x plus 2 is 1 function. Find the inverse of the function f from closed interval minus 1 comma 1 to range of f. Range of f. Okay. Solution. Given f from minus 1 comma 1 to a real number defined like this, f of x equals x divided by x plus 2 for all x belongs to minus 1 comma 1. Look at the domain please. So let us verify 1 function. For all x1 comma x2 belongs to the domain minus 1 comma 1, if f of x1 equals f of x2 implies x1, f of x1 means x1 divided by x1 plus 2 is equal to f of x2 means x2 divided by x2 plus 2. Cross multiply x1 into x2 plus 2 means x1 x2 plus 2x1 is equal to x1 x2 plus 2x2. x1 x2 gets cancelled if you shift that to the LHS. So 2x1 is equal to 2x2. 2 also gets cancelled. x1 is equal to x2 if f of x1 equals f of x2. Therefore, f is a 1 function. Let f of x is equal to y. What is f of x? X divided by x plus 2 is equal to y. Cross multiply. So, x is equal to xy plus 2y. Collect x terms together. X minus xy is equal to 2y. If I take x common, 1 minus y is equal to 2y. X equals 2y divided by 1 minus y. So, denominator should not be 0. That means y not equal to 1. Therefore, range of the function should be the real number except 1. We have verified 1 function, right? F is 1. Let us check onto. To find f inverse, we need to verify onto, for all y belongs to the range, I mean codomain, range of the function, x belongs to minus 1 comma 1 such that f of x is equal to y. F of x is what? X divided by x plus 2 is equal to y. So, from this one we have just now we have solved, x is equal to 2y divided by 1 minus y. For all x, this belongs to minus 1 comma plus 1. Minus 1 comma plus 1. That means f is onto. F is onto. Since f is both 1 and onto, f is a bijective function. Since f is bijective, f inverse exists. Therefore, f inverse from real numbers except 1 to the set minus 1 comma 1 closed interval defined by f inverse of y is equal to x, x is nothing but 2y divided by 1 minus y. For all y belongs to the real number except 1. So, this is in the handbook under 5 mark section. 9th one, an exercise question. If f of x is equal to 4x plus 3 divided by 6x minus 4, for x not equal to 2 by 3, what happens if x equals 2 by 3? 6 into 2 by 3 means 6 by 3 is 2, 2 into 2, 4. 4 minus 4 is 0. The function f of x is not defined when x is 2 by 3. That's why they delete from the set. X equals 2 by 3 except 2 by 3. Show that composition of f and f is x for all x not equal to 2 by 3 excluding 2 by 3. What are the inverse of f? They are also asking what are the inverse of f? Let us see. Solution. Given f of x equals 4x plus 3 divided by 6x minus 4 is defined for all x not equal to 2 by 3. For all x belongs to a real number except 2 by 3. Now consider composition of f and f. So what is this? F of x can be written as 4x plus 3 divided by 6x minus 4, by using equation 1. By using equation 1. Let me denote this as some t. F of t, where t is equal to 4x plus 3 divided by 6x minus 4. Now observe, this is just like f of x. F of x means 4x plus 3 by 6x minus 4. F of t means 4t plus 3 divided by 60 minus 4. 4t plus 3 divided by 60 minus 4. Resubstitute t. But t is equal to this, then f composition of f and f equals 4 into, in place of t, 4x plus 3 by 6x minus 4 plus 3 as it is, whole divided by 6 into, in place of t, 4x plus 3 by 6x minus 4 minus 4. Here nothing means 1 we have. Take the LCM, 6x minus 4, 4 into 4x plus 3 plus 3 into 6x minus 4. Here also nothing means 1. Take the LCM as 6x minus 4, 6 into 4x plus 3 minus 4 into 6x minus 4. This and this gets cancelled. Multiply 4 into 4 16x, 4 into 3 12, 3 into 6 18x minus 12, plus 12 minus 12 gets cancelled. In the denominator also, 6 into 4 24x, 6 into 3 18, minus 24x minus of minus plus 16. Here minus 24 and plus 24 gets cancelled. 16 plus 18 is 34x divided by 34. So we are left with x. F composition f is x only. So clearly it is an identity function. Clearly f composition f is an identity function. Therefore inverse of f is f only. 10th one, an exercise problem. Let f from set of real numbers except minus 4 by 3 to a real number be a function defined as f of x is equal to 4x divided by 3x plus 4 and g from the range of f to real numbers except minus 4 by 3. G from b to a, then find the inverse of f they are asking. It's there in the handbook. Okay. Solution. Given f from real numbers except minus 4 by 3 to a real number is defined by f of x is equal to 4x divided by 3x plus 4 for all the real numbers except minus 4 by 3. If you give minus 4 by 3 here, 3 gets cancelled, minus 4 plus 4 is 0. Anything by 0 means not defined. That's why they eliminate minus 4 by 3 from the set of real numbers. Let me call it as equation 1. Let f of x is equal to y. What is f of x? 4x divided by 3x plus 4. Solve for x here, cross multiply. 3xy plus 4y is equal to 4x. Collect x terms together. 3xy minus 4x is equal to minus 4y. So x is equal to 4y divided by 4 minus 3y. I just multiply this to here, 4 minus 3y. X equals 4y divided by 4 minus 3y. So therefore range of the function should be y should not be 4 by 3. If y is 4 by 3, 3 gets cancelled, 4 minus 4 is 0. Anything by 0 is not defined again. That's why the set of real numbers except 4 by 3. Let, that is the range of the function. Let us assume the function g from b to a, that is range of f to the set of real numbers except minus 4 by 3 defined by g of y is equal to x. X is nothing but 4y divided by 4 minus 3y. Say sum 2 for all y belongs to the real numbers except 4 by 3. Now For all x belongs to the real numbers excluding minus 4 by 3, gaf of x is equal to g of f of x. Observe what is f of x. Look at equation 1, 4x divided by 3x plus 4 using 1. This is of the form g of y. G of y means 4y divided by 4 minus 3y. G of t means 4t divided by 4 minus 3t. G of this means 4 into this divided by 4 minus 3 into this. Okay. So here nothing means 1 we have, take the LCM. That means gaf of x is equal to, if I take the LCM, 4 into 3x plus 4 means, 4 into 3x plus 4 means, 4 into 3, 12x plus 16 minus 3 into 4 is 12x. This and this gets cancelled. 16x divided by 16, 16 gets cancelled, we are left with x. Therefore, gaf is equal to identity function on the set of domain, on the set of real numbers except minus 4 by 3. Say some equation A, and for all y belongs to the real numbers except 4 by 3, y belongs to codomain, that is range of f actually. Fog of y is equal to f of g of y. So from equation 2, g of y is nothing but 4y divided by 4 minus 3y. Now this is of the form f of x. F of x means what? 4x divided by 3x plus 4, right? In place of x, you just replace 4 into 4y by 4 minus 3y divided by 3 into 4y divided by 4 minus 3y plus 4. Here nothing means 1 we have, take the LCM. 4 into 4, 16y divided by 4 minus 3y, and the denominator 4 minus 3y LCM, 4 into 3, 12y, 4 into 4, 16, 4 into minus 3 minus 12y. So 16y plus 12y minus 12y gets cancelled, 16. So fog of y is equal to y. Therefore, fog is identity function on the set of real numbers except 4 by 3. Say some equation B. From equation A and B, clearly f is invertible with f inverse is equal to g. Therefore, g range of f, that is nothing but real numbers except 4 by 3 to the real numbers except minus 4 by 3, defined by f inverse of y equals g of y. G of y is nothing but 4y divided by 4 minus 3y for all y belongs to the real numbers except 4 by 3. This is the inverse of the function. 11th one, worked example. Show that if f from set of real numbers except 7 by 5 to the set of real numbers except 3 by 5 is defined by f of x is equal to 3x plus 4 divided by 5x minus 7. Say some 1. And another function g from set of real numbers excluding 3 by 5 to the set of real numbers except 7 by 5 is defined by g of x is equal to 7x plus 4 divided by 5x minus 3. Say some 2. Then fog is an identity function on the set A and gaf is an identity function on the set B, where A is equal to set of real numbers except 3 by 5, B is equal to set of real numbers except 7 by 5. Identity function on the set A equals x for all x belongs to set A. Identity function on the set B is also x for all x belongs to set B, are called identity functions on the set A and B respectively. Solution. Consider gaf of x. So here we operate f first, f first. So that means In F, the domain is a set of real numbers except 7 by 5 to the real number except 7 by 5. Graph is from A to C, you know, A to B, B to C means A to C. 7 by 5 to 7 by 5 only, defined by G of f of x. What is f of x actually? From equation 1, 3x plus 4 divided by 5x minus 7. This is just like G of y. G of y is 7y plus 4 by 5y minus 3 by using equation 2. So this becomes 7 into this plus 4 divided by 5 into this minus 3. Here nothing means 1 we have. Take the LCM. 5x minus 7. 7 into 3, 21x plus 28. 5 into 4, 20x minus 7 into 4, 28. Plus 28 minus 28 gets cancelled. So 21 plus 20 means 41x. Even in the denominator also, 5x minus 7 LCM, 5 into 3, 15, 5 into 4, 20, minus 3 into 5, minus 15x, minus of minus plus 21. Here plus 15 and minus 15x gets cancelled. 20 plus 41 means, 20 plus 21 means 41. We are left with graph of x is equal to x. For all x belongs to B. Therefore, graph is an identity function on the set B, and fog of x from set of real numbers except 3 by 5 to the set of real numbers except 3 by 5 only, defined as fog of x is equal to f of g of x. Look at g of x from equation 2. G of x is 7x plus 4 divided by 5x minus 3. So this is of the form f of x. F of x is 3x plus 4 divided by 5x minus 7, you know. In place of x, 3 into this plus 4 divided by 5 into this minus 7 using equation 1. Here you simplify, take the LCM as 5x minus 3, 7 into 3, 21x plus 12, 5 into 4, 20 minus 12, plus 12 minus 12 gets cancelled, again minus 41x. Here LCM is 5x minus 3, 7 into 5, 35x plus 20, 7 into 5 minus 35x plus 21. So minus 35 and plus 35 gets cancelled, 41. 41 gets cancelled, x. Fog of x is equal to x for all x belongs to set A. Therefore, fog is an identity function on the set A. 12th one, worked example. Consider the function f from the set 1, 2, 3 to the set A, B, C, and g, another function g from the set A, B, C to the set containing apple, ball, cat, defined as f of 1 is equal to A, f of 2 equals B, f of 3 is equal to C, and g of A equals apple, g of B equals ball, g of C is equal to cat. Show that f, g and graph composition of f and g are invertible. Find out f inverse, g inverse and graph inverse, and also show that graph inverse is equal to composition of g inverse and f inverse. Solution. Given the function f from the set 1, 2, 3 to the set A, B, C, defined like this: f of 1 equals A, f of 2 equals B, f of 3 equals C. That means 1 associated to A, 2 associated to B, 3 associated to C. See this? Clearly it is a 1-1 function, right? Distinct elements have distinct images. That's why it is 1-1 function. And of course onto also. Why? Because every element of the set B have at least one pre-image in set A. So both 1-1 and onto means F is bijective. Since F is bijective, inverse of F exists. F inverse exists and is defined as from B to A, that is F inverse from the set ABC to the set 1, 2, 3, defined like this. F inverse of A is equal to 1, F inverse of B equals to 2, F inverse of C is equal to 3. Say some equation 2. Also G is another function from the set ABC to the set containing apple, ball, cat, defined like this. G of A, the set A, ABC and apple, ball, cat. A associated to apple, G of A equals apple. B associated to ball, G of B equals ball. C associated to cat, G of C is equal to cat. Say some 3. So clearly observe this. Again G is also 1-1 function. Distinct elements have distinct images. And every element of the set B associated to every element of the set B has at least one pre-image from the set A. That's why it is onto also. Since G is both 1-1 and onto, clearly G is bijective. Since G is bijective, G inverse exists. Inverse of G exists and is defined like this. G inverse from the set of apple, ball, cat to the set ABC, defined as G inverse of apple is equal to A, G inverse of ball is equal to B, G inverse of cat is equal to C. Say some 4. Now let us find GOF. GOF, that is composition of F and G, F from A to B, G from B to C means GOF is from A to C. That's why GOF from the set 1, 2, 3 to the set apple, ball, cat, defined as G of GOF of 1. This can be written as G of F of 1. See F of 1, observe equation 1, F of 1 is equal to A. Now G of A, observe equation 3, G of A is equal to apple. Similarly, GOF of 2, G of F of 2. F of 2 from equation 1, it is B actually. G of B from equation 3, it is ball. Then GOF of 3 can be written as G of F of 3. But actually from equation 1, F of 3 is equal to C. From equation 3, G of C is equal to cat. So, the set 1, 2, 3 and the set apple, ball and cat. 1 associated to apple, 2 associated to ball, 3 associated to cat. Clearly this is also both 1, 1 and onto. That's why inverse of GOF. GOF is bijective, so that inverse of GOF exists. So GOF inverse is equal to, from the set apple, ball, cat, from the set containing apple, ball, cat to the set 1, 2, 3, defined as GOF inverse of apple is equal to 1, GOF inverse of ball is equal to 2, GOF inverse of cat is equal to 3. Say some equation 5. Also F inverse circle G inverse, nothing but composition of G inverse F inverse of apple is equal to F inverse of G inverse of apple. This is, look at equation 4, G inverse of apple is nothing but A. So that F inverse of A, by using equation 2, it is 1. Similarly, composition of G inverse and F inverse of ball is equal to F inverse of G inverse of ball. By using equation 4, you can write this as B. So F inverse of B, by using equation 2, it is 2 only. Then composition of G inverse and F inverse of cat is equal to F inverse of G inverse of cat. By using equation 4, you can write this as C. So that F inverse of C, from equation 2, it is 3. Say, call this as equation 6. From 5 and 6, both are one and the same. That means GOF inverse is equal to composition of G inverse and F inverse. Next, 13th one, an exercise problem. Consider a function f from the set 1, 2, 3 to the set ABC given by f of 1 equals A, f of 2 equals B, f of 3 is equal to C. Find f inverse and show that f inverse the whole inverse is equal to f. F inverse the whole inverse is equal to f. Solution. Given the function f from the set 1, 2, 3 to the set ABC defined by f of 1 equals A, f of 2 equals B, f of 3 equals C. Say some equation 1. So 1 associated to A, 2 associated to B, 3 associated to C. Observe the arrow diagram. Clearly it is 1, 1 function. And of course every element of the set B has at least one pre-image from the set A. That's why it is onto also. F is both 1, 1 and onto means it is a bijective function. As it is bijective, inverse of F exists. F inverse exists. Then F inverse from the set ABC to the set 1, 2, 3 defined by F inverse of A equals 1, F inverse of B equals 2, F inverse of C is equal to 3. Say some 2. So A associated to 1, B associated to 2, C associated to 3. Clearly it is both 1, 1 and onto. Since F is also F inverse is also bijective. This is inverse. F inverse is also bijective. F inverse bijective means inverse of F inverse exists. That means F inverse whole inverse exists. So that is nothing but from the set 1, 2, 3 to the set ABC defined as F inverse whole inverse of 1 is equal to A, F inverse whole inverse of 2 equals B, F inverse whole inverse of 3 is equal to C. Say some equation 3. See this? So clearly this is also both 1, 1 and onto. Observe equation 2 and 3. From equation 1 and 3, F inverse the whole inverse is equal to F. Inverse of an element is itself.